Hi, I came across this interesting problem a couple of weeks ago while working on factorizing algebraic expressions. So I've got x cubed minus 1, which can be written as two factors. So I was asking myself, is x squared plus x plus 1 a prime? So if it is a prime, it can be factorized. So that was my hypothesis. So it can be factorized. So if it is a prime, it can be factorized. That means I can write this as x plus a times x plus b. That means it has got two roots. And what I see is x squared plus x plus 1 can actually be written as x plus 1 whole square plus 3 over 4. So for any value of x, so this function is always going to be positive. That means it will never touch the x-axis. That means it can't have any real roots, but it may have imaginary roots, because you can actually solve this using minus b plus minus b square minus 4ac over 2a. So it has got imaginary roots and no real roots. That means this cannot be factorized. So that means it must be prime. So that was my logic. And then I started substituting for different values of x. So I made a table where I gave x from let's say 2, 3, 4, 5 and so on. So for x is equal to 2, what I get is 2 squared, that's 4, 4 plus 2, 6, 6 plus 1, 7. Okay, that's going to be a 7, which is a prime. Oh, that's good. For 3, we've got 3 squared, that's 9, 9 plus 3, 12, 12 plus 1, 13, which is also a prime. But when I come to 4, I get 4 square, 16, 16 plus 4, 20, 20 plus 1, 21. So which can be factorized as 3 and 7. So this is where my logic was questioned. So I figured out that this cannot be factorized. So x squared plus x plus 1 cannot be factorized. But now when I start substituting with integers, I can actually factorize it. So for 5, for example, I will get 31, which cannot be factorized. That means it can be a prime. So for certain values of x, there are prime numbers available when I use this expression x squared plus x plus 1. So then I did some research on prime numbers, and then I found out that x squared plus x plus 41 is a function which is used to generate I think the first 40 primes. So I then made a table. So what I made it is, for different values of x, I've got x squared plus x plus 1 here, and then I can clearly see here that x21, that can be factorized, 57, that's 19 multiplied by 3, and so on. But x squared plus x plus 1, here, that's one here, x squared plus x plus 41, it's always a prime that you see all the way up to, I think it's 40. Excuse me. So up to 40 you can generate primes. So that was an interesting find out that I got while researching on the numbers x cubed minus 1 is equal to x squared plus x plus 1 multiplied by x minus 1. So hope you enjoyed this video.